Okay, we have question number 1, graphing review. So 1A, we have the points 1, 1 and 2, 4. And we want to find the slope between these 2 points. So we're going to use the formula M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So we're going to identify these points above as x1, y1 and x2, y2. Great, so now we can substitute in the formula. So M equals y2 is 4. I'm going to substitute with brackets. y1 is 1. I'm going to substitute with brackets. Again, always substituting with brackets. x2 is 2 minus x1 is 1. Therefore, M will equal 4 minus 1 is 3, 2 minus 1 is 1. And we have a slope of 3, or 3 over 1. So a great idea is to, after the fact, actually draw these points. So we have 1, 1 and 2, 4. And we can clearly see that we're rising 3 and running 1, therefore the slope is equal to 3 over 1. So we're going to use the formula M equals y2 minus y1 over x2 minus x1, the formula for the slope. We're going to identify the points x1, y1 and x2, y2. We're then going to carefully substitute those values into the slope formula, substituting with brackets, then cleaning up the formula, finding the slope, and checking our answer by actually graphing and make sure it's correct. Okay, we have 1b. So we have the points negative 4, 2 and 2, negative 14. So again, we're going to write down the formula for slope. M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And then we're going to carefully identify the points as x1, y1 and x2, y2. So then we can carefully substitute into our formula. So M equals y2 is negative 14. I'm going to substitute with brackets minus y1 is 2 over x2 is 2 with brackets minus x1 is negative 4 with brackets. That means that M equals negative 14 minus 2 is going to be negative 16 over 2 minus negative 4 is 2 plus 4, so we're going to get 6. Then we can simplify. M equals, if we divide the top and bottom by 2, we'll get negative 8 over 3, simplifying our fraction, getting our slope. Now, we could check our answer. However, the numbers are a little bit more complicated, so negative 14 is going to be extremely low. So if we want to graph that, then, and we have negative 4, 2, then we want to put the y-axis about here and the x-axis about here. So then we'll identify the first point, negative 4, 2, and 2, negative 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Notice it goes off the graph. It's going to be a little more difficult. So if you would like to, feel free to check to make sure that that slope is negative 8 over 3, then absolutely. However, we know that it's correct. Okay, 1C. We have 3, 0 and 5, 1, 3, 0 and 5, 1. So M equals, now we've written this formula twice already. We don't have to write the formula every single time. We also don't have to substitute if there's also have to substitute with brackets if there's no negatives involved. So we can simply go for the y value 1, y2 minus y1 over x2, 5 minus x1, 3. M equals 1 minus 0 is 1, 5 minus 3 is 2. Circle your answer. Draw it on a graph. So if we draw a graph, we're going to get the point 3, 0 and the point 5, 1. And we clearly have a slope of up 1 over 2, always checking your answer by graphing to make sure that you know that it's correct. Okay, we have 2a. 2a. So before we were finding the slope, now we are given 2, 4 and 1, n. We don't know what the y value of the second point is, but they've let us know that the slope is 3. So if we very carefully write our formula for the slope, m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay, so again, let's label our points. x1, y1, comma, x2, comma, y2. So let's very carefully substitute in the formula. On the left-hand side, we were given the slope of 3, so we're going to put 3 in for the slope. Then y2 is n, minus y1 is 4, over x2 is 1, minus x1 is 2. Notice I didn't need to substitute with brackets because I didn't have any negatives, but you can substitute with brackets just to be safe all the time. So for example, I could have substituted all of these with brackets, but none of those brackets were necessary. So you get to decide on your level of confidence of substituting with brackets or not. Either way, 3 equals, we have n minus 4 on the top, and 1 minus 2 is negative 1. Then we have a negative 1 on the bottom, so we can times both sides by that negative 1. So on the left-hand side, negative 1 times 3 is negative 3 equals. Now we only times both sides by negative 1 to cross off the negative 1's. Equals n minus 4. Then we can add 4 to both sides of the equation and mirror it, and equals negative 3 plus 4 is 1. Circle your answer. We have n. Therefore, our point is simply 1, 1. I'm not going to circle that answer. It's not an answer. The question says, what is n? That's what n was. That's what we circle. So now we can draw it on a graph. So if we take the point 2, 4, 2, 4, and put a dot at 2, 4, and then take the point 1, 1, and put a dot at 1, 1, label both those points, then we can clearly see we have a rise of 3 and a run of 1 for a slope of 3 over 1, or 3. Therefore, we know our answer is correct. N is equal to 1. So a couple more examples like that when we have to do algebra to find a value, and more difficult algebraic examples. Okay, we have 2b. So again, we have n, 2 and 2, 3, and this time they've told us that the slope is 1. Sorry, m equals 1. So again, we can write down the formula for the slope, but you know what? Why don't we skip that step this time? So we've written down the formula for the slope for many of these last questions, but why don't we substitute right into it? They've given us the slope. We're going to substitute on the left-hand side for m, 1 equals. Now, usually I label the points x2, x1, y1, x2, y2, and feel free to do that, but here we're just actually going to do it. So we have 3 minus 2 over 2 minus n. So let's clean that up a bit. So we have a 3 minus 2 on the top, that's 1, so 1 equals 1 over 2 minus n. Now we have an 2 minus n on the bottom. We want to times both sides by 2 minus n. Now on the left-hand side, we're going to distribute the 1 backwards. If that wasn't a 1, it'd be any number that it was, and that's the number that we'd use to distribute. But 1 times 2 is going to be 2, and 1 times negative n is going to be negative n, equals, on the right-hand side, we're multiplying by the denominator, so that cancels, equals 1. So we have to minus 2 from both sides, so minus 2, and we're getting negative n equals 1 minus 2 is negative 1. Then we can divide both sides by negative 1, and we get n equals 1 again. Interesting. Okay, let's check that answer. So if we draw a graph, and we put the point 1, 1 on the graph, the point that we just found, and the point 2, 3, 1, 2. Excuse me, we didn't find that point. Sorry about that. I didn't write the point down that we found. The point was n comma 2, so we just found n, so that's going to be 1 comma 2. Good thing I labeled my point, making sure. So our point is 1 comma 2, so we can put that point on there, 1 comma 2, and the other point that they gave us was 2 comma 3, so we can put that point on the graph, 2 comma 3, and then we can clearly see we have a slope of up 1 over 1, a slope of m equals 1 over 1, or 1. As they told us in the beginning, our n equals 1 answer is correct. So a little bit more difficult algebra this time, but again, if we have something on the bottom, we can times those sides by that thing and cancel it from where we times it by, and then do some simple algebra to figure out the rest of the answer. Okay, 2C. So we have the point 1 comma 1, and we have the point 5 comma n. So this time m equals 1 over 2, a half. Okay, so again, we don't have to write the formula down for slope every time. M equals y2 minus y1 over x2 minus x1. Let's substitute on the left-hand side of the equation. So m is a half, so on the left-hand side of the equation, so we can say 1 over 2 equals. Then we can do y2 minus y1 over x2 minus x1. So we have y2 is n, minus y1 is 1, over x2 is 5, minus x1 is 1. Keep in mind, the order doesn't matter as long as you stay consistent. You could switch the points, but then you'd have one point being x1, y1, and the other point being x2, y2. Okay, so on the left-hand side, we have 1 half equals n minus 1 is simply n minus 1 over 5 minus 1 is 4. We have a 4 on the bottom. Let's times those sides by 4. 4 times 4. Okay, on the left-hand side, the 4 is over 1. So we could multiply fractions and get 4 over 2 and then simplify it by 2. But we could simply cross-cancel, divide the top and bottom by 2, and then simply get 2 times 1 is 2 over 1 times 1 is 1. We don't need to write that. Equals, again, we only times those sides by 4 to cross off the 4, and we're left with m minus 1. We can add 1 to both sides, and n equals 3. Circle our answer. Remember, write down the point that you figured out right away so you don't make a mistake like I did last time. So we have the point 5 comma 3. Remember, that's not a final answer. N is equal to 3 is our final answer. We're circling that. Then we can draw a graph, and we have 1 comma 1 and 5 comma 3. 1, 2, 3, 4, 5 comma 3, 5 comma 3. Then we can check our slope. So we're going up 1 over 2, and again up 1 over 2. 1 over 2, 1 over 2. Therefore our slope is a half, like we were given. Therefore we know our point is correct. So be very careful with that formula. Be very careful subtracting negatives. 2 negatives side by side makes a positive. Be very careful with what's on the denominator. We're going to times both sides by the thing on the denominator that has the variable on that side. So if we have a number on the bottom, we're going to times both sides by that number. But we have a binomial on the bottom, for example, x plus 1 or whatever it is, we're going to times both sides by exactly that thing. Then we're going to distribute on the left-hand side and clean it up. So we might even be working with fractions like this last example. So be very careful with your algebra after you've substituted into the formula, solving for the variable. Okay, we have 3a. So we are given the points. I'm just going to draw them on the graph. 1, 2. I'm going to erase that weird bracket I have above. So we have the point 1, 2, 3a. We have the point 1, 2. We have the point 2, 3. Then we have the point 3, 4. 1, 2, 3, 4. Then we have the point 4, 5. So, is the following a function or a relation? What we're going to do is imagine a vertical line on the page. And we're going to simply move that vertical line left and right, And as long as the red line or any vertical line only hits your points or graph once, you know it is a function. So it only hits once for all of the points. Therefore, we know it is a function. So we say function check mark, or yes, it is a function. So again, for a function, we're going to be using what's called the vertical line test, running something vertically along the page like a pencil or your mind, and figuring out if the graph hits more than once. If it hits more than once, it's not a function. If it only hits once, it's a function. Okay, we have 3b. Notice 3b is literally exactly the same as 3a, but without this point right here. And instead, we have the point 2, 2. So if you want to, feel free to copy this down, but just remember that all we have to do is find out if we have 2 points on top of each other. So here we have 2 points on top of each other, 2, 2, and 2, 3. So the rest is a function, but right here it's not a function because we have 2 points on top of each other. So what you want to look for is you want to look for the same x value. So let's say you're given information with the same x value, and then you're given 2 different y values. Well, we know that it is not a function. Not a function. Or function no, or whichever. So again, vertical line test. Run a pencil or a vertical line across the page. If it ever get more than one answer for an x value, we say more than one output for every input, then it's not a function. So these can be applied to all sorts of things in real life. I put gas in my car, it drives a certain number of kilometers. Function. I eat food. My energy is a function of how much food I eat. Now I'll tell you about not a function. So a great example of not a function would be a biological child. So a parent or parents may have one child, but they also may have more than one child. And that is a perfect example of not a function, and we call it a relation. When an input, like a parent, can have more than one output, like a biological child. Okay, 3c. So let's check out this table of values. So we have x and y. On the x column, we have 2, 2, 3, 4. And on the y column, we have 2, 3, 4, 5. And notice that we have 2 of the same x value, so we can circle where we have 2 of the same x value. And notice we have 2 different y values. Therefore, we can say not a function. Now, if the question says, is this a function, and you say no, that's good enough. But in your notes, at least once on the page, say not a function. And if it is a function, say yes, it is a function. But not a function, because we have 2 separate y values for the same x value. One single x value has 2 different y values. Not a function. Therefore, we call it a relation. And put a check mark there, because if you accidentally write not and then relation nearby, then you may get a mark off. So if you do want to say not, say maybe not a function. I'm missing a C. Function, F-I-U-N-C-T-I-O-N, excuse me. So it's called a relation. Okay, D. So we now have a table of values, x and y. On the left column we have 1, 2, 3, 4. And on the right column we have 2, 3, 4, 5. And notice we don't have any of the same x values, so we can say function. Notice it's the same as the graph above. So in A, 3A. So D is exactly the same as 3A, and B is exactly the same as C. I just showed you in different formats. Okay, one quick moment. Okay, we have 3E. Okay, so this time they've given us a graph, and they've asked us if it's a function. So we have the point -1, 2. We have the point -1, -2. Oh wait, should I keep bothering to draw the rest? No. We have 2 points on top of each other, not a function. That was one lazy way to write function. So, is it a function? No, it has 2 points on top of each other. Therefore, we call it a relation. Like the example we talked about earlier, a biological child is a great example of a parent is a great example of a function whereby having a biological child, the input is the parent, the x value, the y value is the output, the child. You can have one child, but you can have more than one child. Therefore, a biological child from a parent is a great example of a relation. But basically, we can't have 2 points on top of each other. If we do, it's a relation. If we don't, and we only have one y value for every x value, it's a function. Okay, 4a. Is the following discrete or continuous? So we have a little graph, and I'm not going to be perfect about it. We have some points all over the place. They kind of do some things, but don't really do much. So, is this discrete or continuous? So, it is what we call discrete. It is called discrete because the points do not continue. Obviously, these words are taken from Latin and Greek and Egyptian, I'm not exactly sure, countries all over the world. And we take these words and they mean something. So discrete, one thing at a time. If you're weighing pennies, you're putting 1 penny on a time. Weighing each penny, weighing the total number of pennies, that's discrete. Whereas walking to the park, well, you're continuously at each location in between, therefore continuous. So we have B. Again, we have another graph. And these points do follow better lines, but is just discrete again. Now I could write the word again, but I'm just going to put 2 little ticks below the other word discrete, meaning exactly what it is from above. Okay, C. We have a graph centered about here, and the line looks something like that. And because it is a continuous line, this is what we call continuous. Like if you were walking to the park, your every step in between, your every bit in space in between each and every step. Something else continuous, for example, your weight. You eat food and you get a little bit more weight, and the weight goes up and down as you slowly eat, etc. Driving in your gas tank. Well, your gas tank slowly goes down, and then you slowly, continuously at the gas station fill it up. Discrete and continuous. Basically, if it's a bunch of points, it's discrete. If it's a line or a continuous curve, it's continuous. Okay, are the following linear? 5A. So, linear, the root words means line. Is it a line or not? So we have a circle. It's not a line, so it's non-linear or not linear. So again, it's got to be a line. If it's a line, it's linear. If it's not, it's not. Okay, we have B. So we absolutely have a line. It is linear. Okay, C. We have this interesting rising function. Not linear. Again, the question says, are the following linear? So if you say not, well then it's not. Okay, D at the top right. So this time we're given some points, x, y. And on the left column we have -4, -2, 0, 4, 8. On the right column we have 0, 3, 6, 12, 18. So we could put these on a graph. We could draw all these points on a graph and make sure that it shows up in a line. So that's one way. But let's figure out another way. We want to figure out what the change in y, that's change in delta, a symbol for change in y over change in x. Where have we seen that formula before? It's just y2 minus y1 over x2 minus x1. But we can also look at it completely differently. What if we just say, what's the y value going up by? +3. What's the x value going up by? So you want to think, we're at -4, we're getting to -2, which means we're adding 2. Okay, interesting. So that means that so far the slope, m, is just 3 over 2. Okay, does that pattern continue? So we get +3 over, again, +2. So again, we have a slope of 3 over 2. Okay, interesting, but then we go up 6 plus 6. And again we go up 6. Okay, what's happening here? Okay, but then we go up 4. So up 4, and then we go up 4 again. So let's see if this works. So now we have a slope of not 3 over 2, but 6 over 4. And if we simplify that fraction, it is 3 over 2. And because we have the same slope in both, it is absolutely linear. And we don't have to bother graphing it. Circle your answer. Oh, circle all your answers. Not linear, not linear, not linear. How many did I circle? Discrete, discrete, continuous, not a function or relation. Function, yes, not a function. Function, not a function, therefore a relation. And I've been circling my answers before that. Great, so again, it's linear if it makes a line. If you're given points or given a table of values and you're too lazy to figure out what it goes up by, just draw those points on a graph and find out if it goes up on a line. But either way, if it's a line, a straight line with no curves, no edges, no bumps, no nothing, a straight line, it is linear. If it's not that, it's not that. Again, if you have a table of values, you just want to calculate the slope of every single point very quickly, what the y goes up by over what the x goes up by, write down that slope each time and make sure they simplify all to be the same slope. Linear, not linear. So a brief bit on this before I continue with domain and range, a little bit more difficult. Function versus relation, discrete and continuous, and linear, you just want to learn what they are. They're each going to be a question on the test. It's going to be an easy yes or no answer, and it's so simple. Just learn what those three things are. Keep in mind, it's obviously on the yearly review sheet, which I highly recommend you make in preparation for a test. Write down linear, not linear, discrete, continuous, function, relation. Know what each one of those are, and guarantee 100% on that section of the test. Okay, 6A. So, find the domain in set and interval notation. So we first of all have a number line, and I'm only going to put the value that I care about. The 2 has the dot, so I'm going to put the dot there. I'm going to use red so you can clearly see it on this black line. And we're going to the right, either represented by shading or a little arrow above and pointing to the right. So, first of all, we know that x needs to be, well, I'm going to put a few ticks on here. So I'm going to put 3, and I'm going to put 1. So I know that I'm shading to the right of 2, so x needs to be greater than 2, and we have a closed dot at that location, so it's greater than or equal to 2. So this is set notation, and this is the laziest way to write set notation. Some teachers force you to in front write x vertical bar, meaning we're talking about x, and then after say comma XER, meaning x can be an element of all real numbers. And it was that because we shaded the whole number line and we didn't just identify distinct points where it may be something different. Then they make you do curly braces around the front and the back, and then that is what's called set notation. Interval notation is we're going from 2 to infinity, and we put a round bracket in front of infinity because we don't, or after infinity because we don't include infinity, and because we're a closed dot, we draw a square bracket. So I'm going to circle both my answers separately. We have set notation and interval notation. So what I'm going to do is I'm going to choose an arbitrary number that's greater than 2. So let's say x equals 5 star. Well, then I'm going to set it up. X is greater than or equal to 2 is what I said. I'm going to put 5 in for 2 and say greater than or equal to 2. Now I want to remember that the alligator eats the bigger things. So the teeth face towards the bigger thing, and the bigger thing is that. Therefore, we are correct. Sorry, don't check your checked answer. Check your work that you did. Okay, so I'm not going to do that arbitrary number thing with the alligator teeth again. I'm just going to keep going. So this time we have a number line, 6b. This time we have a number line and we have 3 with an open dot at 3. And we're shading to the left, either represented by that or an arrow going up and to the left. So this time we're going to be less than 3. So I'm going to put a few numbers on there to remind me. So we want less than 3, numbers that are less than 3, like 2. So we say x is less than 3. Then some teachers like you to say x vertical bar, comma, XER if you continuously shaded, and then curly braces around it. But remember, the only real part that matters is the part in the middle. Once you get to university, that's all they're going to ask for. So this time we're doing x is less than 3 in interval notation. So that means that we're going to be less than 3. So our lowest number is negative infinity, round bracket, comma, 3. And we're going to put a square bracket this time. You may ask yourself, what do you mean by these square and round brackets? Well, first thing, top right, round brackets around infinities. We don't include infinity. Then if we have closed dots, it's greater than or equal to or less than or equal to. If we have open dots, it's less than or greater than. When it's above, in red, less than or greater than, we use square brackets. And when it's open dots, we use round brackets or not including. We're soon going to learn that if we have square brackets and greater than or equal to's and closed dots, we do solid lines. And below, if we have open dots, greater than or less than, and round brackets, we do dotted lines on a graph. Okay, I'm just going to shrink this stuff a bit so I can get another question on this page. I'm sure you're not using as much graph paper as I am. Okay, C. This time we have a number line, and we have 2 and 3. And we have a closed dot at 2, and we have an open dot at 3, and we're shading in between, represented by arrows going in both directions in between. So This time it's a between, and the way we're going to do betweens is smaller number, less than, variable, less than, bigger number. Again, smaller number, less than, variable, less than, bigger number. Every single time. Now, we include the 2, so equal to, and we don't include the 3, so not equal to. Feel free to write x vertical bar, comma, xer, because we're continuously through these points. And then in interval notation, we are square bracket 2, comma, round bracket 3. Circle your answer in the last question. So we have greater than to the right, we have less than to the left, we have closed dots, we have open dots, and we have betweens. Smaller number, less than, variable, less than, bigger number. Do not forget the key in the top right-hand corner. Great, so now we're going to do domain and range on a graph. Okay, 7a. So find the domain and range in words, a number line, set, interval, and list where necessary if it is a function. So, is it a function? Okay, so for this first one, our domain, represented by d colon, in words, I'm going to, first of all, let you write this on your own. X can be an element of all real numbers. Fine, I'll write it. X can be an element of all real numbers. So that is what we call domain in words. Now on a number line, we would just draw a number line and we would scribble the whole thing. Now we have set notation. So we learned set notation in the last question, 6. So that's simply XER. X vertical bar in front. And that's why it's probably a good idea to practice doing that XER thing. X, funny looking ER. That is in set notation. In interval notation, we just say negative infinity to infinity. Interval notation. And then as a list, we'd only do it as a list if it's each individual point. I don't even cover those. If they just give you some x values and some y values, you just say x equals, y equals. It's too easy to even explain. So that is domain. Now, I'm going to skip this question and do it on another page. Now let's do the range. I hope you're not writing nearly as you visualize on this screen. So now we're going to do the range. So not the domain anymore, the range. Not the x anymore, it's now y. Y can be an element of all real numbers. Then it's no longer x, it's y. And the interval notation is the same. So again, the domain and range in words. X can be an element of all real numbers. Then the range. Y can be an element of all real numbers. On a number line, it's exactly the same. Just shading the whole thing because you can be anything you want. Then in set notation, just simply XER. Vertical bar, squiggly lines around it. Interval notation, open round bracket, negative infinity, comma infinity, close round bracket. So instead of D colon for range, we do R colon, and then Y vertical bar, YER, squiggly brackets around it, open round bracket, negative infinity, comma infinity. Feel free to pause the video and copy that down, but that is the answer to that question. Okay, 7b. So, find the domain and range in words. So, in words, x can be greater than or equal to 1 and less than 7, because x goes from 1 to 7, and we're greater than or equal to 1 and less than 7. We're greater than equal to, because we have a closed dot that we learned in the key in the last question, and only less than 7 because we have a round dot. Okay, set notation. So, remember, this is a between. So, smaller number, 1, less than, variable, less than, bigger number, 7. We're including 1, so we'll say equal to for the 1. 1 less than or equal to x, less than 7. Then we can say x vertical bar and put squiggly brackets around it, because that's what we're talking about. Now we can say 1 comma 7, and because we're including the 1, we can say square bracket, and we can put a round bracket around the 7 because we're not including. So that's in words. Oh, I forgot a number line. So now on a number line, I'm going to draw a number line. I'm going to put 1. I'm going to put 7. Notice I didn't count perfect squares. Who cares? Put arrow tips on my number line. And then I'm including 1, so close dot at 1. Open dot at 7 because I'm not including, and shade in between. Okay, y. I'm going to do y off to the left here. So, y can be greater than 1. Not equal to because it's open dot, and less than or equal to 4. Set notation, smaller number, 1, less than, variable, less than, sorry, I forgot to call this range, colon, and above I forgot to say D colon to represent that I'm talking about domain. So now I'm down below in red for the range, I forgot D colon above. So smaller number, 1, less than, variable, less than, bigger number, and we're including the 4. We can say y vertical bar in front, squiggly brackets, and then we can do our 1 comma 4, round bracket around 1 because we're not including, square bracket around 4. Lots of times I like to use my hands for x, and then sideways for y, and go, okay, yeah, y totally goes from 1 to 4. Okay, 1 to 4. And I forgot a number line, so let's do a number line. Let's say 1 and let's say 4. Open dot at 1, closed dot at 4, scribble in between them. I forgot my arrow tips on my number line. Okay, so notice we can have domain and range in words, set notation, interval notation, and on a number line. Notice how similar most of it is to each other. I'm going to circle in blue the similarities and differences. So x is domain. Again, we're talking about x and we talk about x. Then range is y, and we're talking about y, so we talk about y, and all the rest is the same. Obviously, they're going to have different domain and ranges in words and set notation and interval notation on a number line, but very similar in nature. Okay, let's look at some more complicated shapes. Okay, 7C. So we have a parabola. Feel free to sketch that parabola. So we have our domain D colon. In words, X can be an element of all real numbers. I'm not writing that again. X can be an element of all real numbers. So that is what the set notation is. XER, we're talking about X, squiggly brackets around it. Okay, interval notation, we're going from negative infinity to infinity. On a number line, again, we would just scribble the number line. Okay, range in red. So, y must be greater than or equal to 0. Feel free to write that in English. Y must be greater than or equal to 0. But we can just say y greater than or equal to 0. Y vertical bar. Now, because y can be every single tiny point above 0, we say YER after. Again, find out from your teacher. Okay, so, squiggly bracket in front. Okay, so y, we're going from 0, we're including 0, and we're going all the way to infinity. And on a number line, oh yeah, so square brackets because we're including 0, infinity we don't include. So on a number line, we'd mark 0, we put a closed dot, and we would shade in that direction. Okay, so again, I did not write down in words this time. X can be an element of all real numbers. Y must be greater than or equal to 0, and that is a parabola. The equation in blue, y equals x squared, the shape that we're going to do a ton of next year. And in physics, like when you throw a ball, it always makes a parabola. So that is what we have. Set notation, interval notation, and on a number line. Oh, is it a function? Excuse me, let me go back. 2 questions. Is it a function? Yes. Is it a function? Yes. Is it a function? Yes. Y-E-S. If you run your pencil vertically along the page and the graph only ever hits once, function, 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 etc. Okay, so now let's take a look at this circle, 7D. So, first of all, let's get something out of the way. Our vertical line test fails. So it failed the whole time, so not a function. Okay, so let's do domain first. So again, in words, I'm not going to keep writing it down. X can be between and including 2, -2, all the way to including 3, because we have points on both sides. So if x goes from 2 to 3, smaller number, less than, variable, less than, bigger number. Excuse me, -2 to 3, smaller number, less than, variable, less than, bigger number. Because we have points on both sides, we include it. Then we can say x vertical bar, squiggly bracket in front, comma, XER after, close squiggly bracket. Just to let you know, the R is actually like this with an extra line here, if your teacher is that fussy about it. Okay, so now, because we're including -2 and going all the way to 3, we use square brackets. Then on a number line, we say close dot at -2, close dot at 3, and we shade in between them. Okay, so now let's do range in red. So range, again, y can go from -6 all the way up to -1. But I'm only going to do it in set, interval, and word. So y again goes from -6, less than, variable, less than, bigger number, -1. Y vertical bar in front, curly braces around. Then, in interval notation, oh, forgot the equal to's. I'm going to write those in blue, forgot the equal to's. So, we're equal to because we have closed dots on both sides of the circle. So, then our interval notation will just be, whoops, I'm still in blue, -6 to -1. And if we draw a number line, we can put -6, we can put -1, we can put closed dots on both sides, and we can shade in between. Okay, so domain and range, a much bigger part of math than the previous questions. So question 1 and 2, slope, huge. 3, 4, 5, functions, relations, discrete, continuous, linear, not so much. Domain and range, huge. Would you go out on a date with your grandmother's friend? Probably not. That's outside of your domain. Are you allowed to drive a tank? No, you're not in the military. That's outside of your domain. So, domain and range, huge things. Do you go to high school with all of your friends? They're all of your domain of your friends. Domain and range, huge. We have domain for X, range for Y. So range is just like domain, as domain is for X, as range is to Y. We can do domain and range on a number line, in words, in set notation, and in interval notation. Notice I haven't been circling my answer because everything I wrote down was the answer. Okay, now getting into some more equations on a graph using algebra. Okay, number 8a. So we are going to be using the equation y equals mx plus b, where m is the slope and where b is the y-intercept. Okay, so they've given us some information. Remember, m is slope, so in 7a they've said m equals 4, comma, y-intercept is -1. I'm going to write it down properly, 0, comma, -1. So that is a y-intercept of 0, -1 with an x value of 0. That is the correct way to write a y-intercept. Okay, so we can simply substitute in the equation. We have y equals our m value in our equation from above is 4x minus 1, circle your answer. Okay, 8b. So we have m equals 3 over 2, and we have a y-intercept of 0, comma 2. So then we can write down y equals 3 over 2x plus 2. Circle your answer. Okay, C. So I'm not going to keep writing down the question. We have a slope of -1, y equals -1x, and a y-intercept of 1/2, so plus 1/2. So what if you have a fraction? D. So this time we have a slope of 0. So y equals 0x and a y-intercept of 2 plus 2. Now we don't say 0x, so we clean it up and say y equals 2. That is a horizontal line, y equals 2. A flat horizontal line. Okay, E. Slope of undefined and an x-intercept of -3. I'm going to do this question up top where I have more space. E. So, again, a slope of undefined and an x-intercept of -3. Well, I don't know what the equation is because what does an undefined slope mean for y equals mx plus b? So, let's draw a line, a graph, and put a point at an x-intercept of -3, a point of -3, 0. Now it's saying the slope is undefined, and we just learned that if we have a flat slope of 2, it's a y equation, y equals like 2 in the last example. I'm going to quickly draw that down below. So y equals 2 would simply be xy, and then a line through the point 0, 2, where every single point on that line has a y value of 2. The equation y equals 2, a horizontal line with a slope of 0. But this one, the slope's undefined, so that means it's a vertical line. Meant to go through that point. I'm going to label some points on the line. -3, 1, -3, 2. Wait, something's happening here. X is the same each time. What is x the whole time? X equals 3, x equals 3, and that is the idiosyncrasy of that question. If you have an undefined slope and an x-intercept or any x value, the equation of the line is just x equals that number. Just like in the question before, 8D, where y was the same the whole time, so it's a flat line, y equals 2, and a horizontal line of that. Okay, this next one, OE, so F. Excuse me, some EF. Oh, okay, so, excuse me, I just did F. I'm going to switch those, and now I'm going to do E. Okay, a slope of 0 and a y-intercept of 0. Well, we just learned that a slope of 0 is a y equation. I'm going to write this one down. Slope equals 0, y int equals 0. Notice I'm actually now doing E when I accidentally did in blue above F. Excuse me. Okay, so now we have a slope of 0, so we learned that a flat slope of 0 is always y equals. Now what's a y-intercept of 0? Well, that's the point 0, 0, so the equation is simply y equals 0. Again, feel free to draw that line. It's the x-axis. This line is actually the equation of the x-axis, y equals 0. Okay, and then now, this time we have a slope and an x-intercept. So the equation doesn't allow for an x-intercept, but only a y-intercept. So what I'm going to do is I'm going to draw this first. So we have an x-intercept of 1. Oh, excuse me. G. FG. So okay, G continued. So we have an x-intercept of 1, the point 1, 0. G, 8G. So we have an x-intercept of 1, the point 1, 0, and we have a slope of up 1 over 2. Up 1 over 2. So this time we'd have a slope of down 1 over 2 in the other direction. So if we were to draw a line between those 2 points, we would have a triangle. And we can clearly see that if I enlarge that triangle off to the right, we're going over 2, up 1. So what if we only went over 1? Well, then we'd be going up a half by similar triangles. Keep in mind that may be a much more difficult calculation of that similar triangles. But we can clearly see that we have a y-intercept of a half and our slope of, excuse me, because it's below, it'll be negative a half. So we can clearly see that the equation is going to be y equals our slope given 1/2 x, and then finding our y-intercept to be negative 1/2. Circle your answer with similar triangles. Very interesting question. In the next few questions, we're going to learn how to figure out what that is later in the exam review. So sometimes they just give you x and y value, or an x value, or a slope value to substitute in along with the y-intercept. Sometimes you have to do some little bit of algebra or graphing it or thinking about it a little bit. But basically, positive slopes up to the right, horizontal slopes 0, negative slopes down to the right, and undefined vertical slopes. Sorry about the confusion with E and F. Okay, 9a. So we have the equation y equals negative 3x minus 4. Our slope m equals negative 3. And our y-int is equal to 0, comma, negative 4. You can be lazy and just say y-intercept equals negative 4. But I like to do this because it really helps my more advanced math, reminding me that for every y-intercept, x is 0, and vice versa. For every x-intercept, y is 0. Okay, 9b. We have y equals 3 over 2x minus 2. Therefore, we have our m equals, I forgot to circle my answer in the last question. Therefore, m equals 3 over 2, and our y-int equals 0, comma, negative 2, circling our answer. Okay, C, y equals 0.02x. Well, m equals our slope 0.02, who cares, that, and our y-int is equal to 0, comma, 0. There isn't one, therefore the number off to the right is just plus 0, so that's what our y-intercept is. Okay, D, the equation y equals x. Well, we have a 1 in front and we have a plus 0 over here, therefore our y-intercept is 1. And because they specifically asked in the question identify the slope and the y-intercept, I don't have to keep writing y-int equals. I can just tell them what it is. Okay, E, y equals 4. Well, don't know what this is, so I'm going to draw it. So if we have a graph, x, y, we have the point 1, 2, 3, 4, 0, comma, 4. Now, y is 4. Where else is y 4? Y is 4 here at 1, comma, 4. Y is 4 over here at 3, comma, 4, which means that we have a horizontal straight line, and that the equation of the line is simply y equals 4, whereby our slope m equals 0, and our y-intercept is simply 0, comma, 4. Circle your answer. Okay, F, x equals 2. Okay, so let's draw this line here. Now, x is 2 right here. Where else is x 2? Well, that point's 2, 0. This point is 2, 1. This point is 2, 2, meaning the x values are all 2 here, so that's a vertical line. Meaning we have an undefined slope. Therefore, x equals 2 is the equation of the line. Excuse me, I don't know why I'm writing that. Where the slope, m equals u and d. This time I'm going to say y-int, none. We have no y-intercept. The graph doesn't go through any y-axis. Therefore, it has an undefined slope and no y-intercept, or y-intercept none. Okay, E, F, G. So we have x equals 0. Well, we just learned in the last question that we have an undefined slope. So we can say m equals u and d when we have an x value. I'm going to draw this graph. Where is x 0? Here at 0, 0. Here at 0, 2, etc. We have a vertical line. The y-axis is called x equals 0, and the equation is x equals 0, where the slope is undefined, and the y-int infinite. We have an infinite number of y-intercepts because it just keeps going through y-intercepts, therefore y-intercept infinite. Great, so we learned in the last question 8 to fill in y equals mx plus b. Now we learn to read y equals mx plus b with a whole bunch of idiosyncrasies. Okay, so we have here 10a. So find the equation in slope point form. So let's write down the point that we're given, 2, negative 3, and m equals 4. So the equation is y minus y1 equals m open bracket x minus x1. So this formula should be very familiar because if I divide both sides by this, it just goes down here and it's below that, and that's exactly the equation of slope. So remember, these are very similar formulas. Let's put a box around that formula. We're going to use it a bunch. So we're going to say y minus, then the y value is negative 3. We can substitute negative 3. The slope is 4. X minus the x value. We don't need to substitute in brackets because we don't have a negative. Y minus negative 3 is y plus 3 equals 4 open bracket x minus 2. Circle your answer. So that is the equation in slope point form. We have a slope and we have a point. In math, we call it like it is. Okay, so B, I'm not going to keep writing the information and then writing the formula. So there's the formula directly above. You can see that we have the point 1, negative 3, and a slope of a half. So we can say y minus negative 3 equals 1/2 open bracket x minus 1. Cleaning it up again, negative negative plus 3 equals 1/2 x plus 1. Circle your answer. Excuse me, x minus 1, x minus 1, x minus 1. I'm correcting above x minus 1. Okay, C. So we have a y value of negative 3 again. Sorry about all these exactly the same types. Equals a slope of 0, open bracket, x minus 0. So 0 times anything is 0. So the equation is y plus 3 equals 0. That is in slope point form, a very odd version of slope point form. But 0 times anything is just 0, so gone. Okay, D. So again, this time we have an undefined slope, and we learned in the last time if we have an undefined slope, the equation has to just be x equals the x value we have, 0, and that is the equation in slope point form, even though it doesn't really look like it. Okay, E, top right. So we have the equation 2x plus 3y equals 6. And it's asking us to write in the equation of slope point form. Well, first things first, we need a slope. So we have to subtract 2x from both sides. Then we have to divide both sides by 3. And y equals negative 2/3 x plus 2. So notice we have a slope. We have m equals negative 2/3. And we have a point, the y-intercept, 0, 2. So now we can substitute into the equation of slope point form. So we can say y minus the y value equals m, the slope, open bracket, x minus the x value. Now x minus 0 is just x, so we can say y minus 2 equals negative 2/3 x. And again, that is the equation in slope point form, even though it doesn't look exactly like it is. So slope point form, just the equation with a slope and a point, very similar to y equals mx plus b. However, that y equals mx plus b just has a slope and a point, which is specifically the point of the y-intercept. Okay, 11a, identify the slope and the point. So if I write down y minus y1 equals m open bracket x1, our equation in slope point form, and we're given y plus 3 equals m 1/3 open bracket x minus 2. We can clearly see that we have a slope of 1/3, and clearly see that we have a point of opposite of what you see inside with x, 2, comma. If you see negative 2, it's positive 2. And then opposite of what you see with y. We see a positive 3, so negative 3. Feel free to reverse that process like we did in the last question and substitute those back into slope point form and make sure that it's correct. Okay, B. We have y minus 4 equals negative open bracket x plus 2. Excuse me, I'm going to rewrite that plus 2. Okay, so we have an m value. Well, what's in front of the brackets? Well, we have a negative, so that's negative 1. We have a slope of negative 1, or negative 1 over 1. And then we have a point of opposite of what you see inside the brackets with x, negative 2, comma, opposite of what you see with the y, positive 4. Circle your answer. Again, feel free to use the last question to substitute this back in. Okay, C. We have y plus 2 equals x. Okay, interesting. So, first of all, technically there's brackets around the x and a 1 in front. So we have an m value, a slope of 1, and we have a point opposite of what you see inside the brackets with x. Nothing's inside the brackets with x, therefore there's a 0 inside the brackets with x. And the opposite of the thing attached to the y is going to be negative 2. Circle your answer. Okay, D, some interesting ones. Y equals x. Okay, well again we have a slope of 1 in front of the x, so we say m equals 1. Then we have a point. The thing inside the brackets with x is 0, the thing inside the brackets with y is 0, and a very simple question in the end. Okay, top right, E. We have y plus 1 equals 0. Okay, so this question, m, well, technically there's a x plus 0 over here. So the slope is just 0, and then the point is just the thing opposite of what's inside the brackets with x, 0, comma, opposite of what's attached to the y, negative 1. And then we have f, where x equals 0. Now some people would write this 0 equals x. Excuse me, 0 equals x. Now technically there's brackets around the x's and there's a 1 in front. But what is this? Well, this is an odd looking equation, especially because it's technically in slope point form. We have nothing on the left hand side, which just means that we have an undefined slope. If the equation is x equals m equals u and d, and then the point that we have, the opposite of what's inside the brackets attached to the x is 0, comma, the opposite of what's inside the brackets attached to y is 0, comma, and circle your answer. A very interesting, odd question in slope point form. Okay, number 12, we have the points negative 2, comma, negative 2, and 4, 1. Okay, so we are simply going to first find the slope. So let's write down the equation. M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Put a box around our formula. Then we'll find it. M equals 1 minus negative 2 over 4 minus negative 2. M equals 1 minus negative 2 is 1 plus 2. And 4 minus negative 2 is 4 plus 2. Again, m equals 1 plus 2 is 3. 4 plus 2 is 6. Therefore, m equals 1 over 2. Circle your partial answer. Then we can go into the equation, y equals mx plus b, put a box around our formula, and substitute. So first things first, we're going to substitute our slope we just figured out, y equals 1/2 x plus b. Don't know why I put brackets around x there, but now we have a point to substitute, so let's take the easier of the 2 points, 4, 1, identify the point as x, y, and substitute. So on the left-hand side, we can say 1 equals 1 over 2 times the x value, 4 plus b. Now the 4 is over 1. On the left-hand side, 1 equals 1 times 4 is 4. 2 times 1 is 2 over 2 plus b. 1 equals 4 divided by 2 is 2 plus b. We can minus 1 from both sides, and we can mirror it. B equals, sorry, we can minus 2 from both sides. Excuse me. If we minus 2 from both sides, I'll let you have a second to erase that and recopy that down. 1 minus 2 is -1 equals b. Circle again your partial answer, and we can rewrite it. Y equals our slope 1/2 x, and then our b value -1, going right back into slope-intercept form. So let's check this out, see if it all makes sense. So we have a point of -2, -2, and a point of 4, 1. Let's check the slope. First of all, up 1 over 2, up 1 over 2, up 1 over 2, absolutely, and we absolutely have a y-intercept of 0, -1. Therefore, we've absolutely done it correctly. So that question is extremely classic. 2 points and find the equation from both points. You might have to find the equation in a different form, which we'll now get into. So again, very classic 2-point question. Lots of word problems. Just give you 2 points, and then you have to figure out what the equation is, and we're going to do a little bit more of that in the next chapter. Okay, number 13, write in y equals mx plus b. So we have the equation 13a. We have y plus 3 equals 1 open bracket x minus 2. So notice we have a 1 in front. That 1 doesn't matter when we distribute the 1. The brackets are unnecessary. So we just have to get it. So we have to just minus 3 from both sides. So we can say y equals x minus 5. And that is the equation y equals mx plus b form. Okay, b. We have y plus 4 equals m open bracket, 2/3 open bracket, x plus 3. So we can do a couple of things. First of all, we could distribute this thing in front. So let's do that. 1, 2. We could have just times both sides by 3 initially to get that 3 off the bottom, but all the same. So y plus 4 equals, if we distribute, 2/3 times x is 2/3 x. And if we multiply 2/3 by 3, the 3's cancel and we're left with +2. Feel free to go back to multiplying fractions and learn better how to do that in grade 8. But 2/3 times 3 is simply 2. We can minus 4 from both sides. So y equals 2/3 x. 2 minus 4 is -2. Circle your answer. Okay, C. So we have y plus 2 equals -1/2, open bracket, x minus 3. Now again, we could get rid of that, we could distribute that -1/2, but we could also times both sides by 2. Again, I'm going to decide, I'm just going to distribute the -1/2. So we can say y plus 2 equals -1/2, x, and then -1/2 times +3. A negative times a negative is a positive, and -1/2 times 3 is simply 3/2. Again, go practice adding and subtracting fractions. So now we have to minus, or multiplying fractions. Now we have to subtract 2 from both sides, so y equals 1/2 x. and 3 over 2 minus 2. Again, go learn to add and subtract fractions, or do it on your calculator, or whichever. But 3 over 2 is 1/2. Minus 2 is simply negative 1/2. Notice I forgot the negative in front of the slope in the line in the answer, so I wrote it in red. Okay, D. So we have x plus y plus 4 equals 0. This is in what we call general form. Ax plus by plus c equals 0, or ax plus by equals c. Okay, so we can simply subtract x from both sides and subtract 4 from both sides. So y simply equals negative x minus 4 in slope-intercept form, y equals mx plus b. Okay, E, we have 2x plus 1/2 y minus 4 equals 0. So let's start by subtracting 2x from both sides and adding 4 to both sides. So we get 1/2 y equals negative 2x plus 4. Then we have a 2 on the bottom. We simply want to times both sides by that 2 and distribute it backwards. So 1/2 times 2 is simply 1. So we have y equals negative 2x times 2 is going to be negative 4x. And positive 4 times 2 is positive 8. Circle your answer in slope-intercept form, y equals mx plus b. Okay, F. We have 1/2 x minus 2/3 y plus 1 equals 0. So this time, before I start to add and subtract to both sides, I want to get rid of those denominators. And in order to do that, I have to times both sides by the LCD. The lowest common denominator between 2 and 3 is 6, so I'm going to times both sides by 6. When I times the first fraction 1/2 by 6, 1/2 times 6 is simply 3. Then when we times the second fraction 2/3 by 6, we're going to cancel. 6 divided by 3 is 2, times 2 is negative 4. Y, 1 times 6 is positive 6, equals 0. So now we have to get into y equals mx plus b form, so we can subtract 3x from both sides, and we can subtract 6 from both sides, and we're going to get negative 4y equals negative 3x minus 6. Then we can divide both sides by negative 4, and we're simply going to get y equals, whoops, I have 2 negative 4s on the bottom there, sorry about that. Divide both sides by negative 4. So negative divided by negative is going to be a positive, and then we can simplify the fraction to be 3/2, dividing the top and bottom by 2. So timesing both sides by the lowest common denominator in the last question. If those multiplying and adding and subtracting fractions are difficult, make sure you go back to grade 8 and check out the introductory videos on adding and subtracting and multiplying fractions. So that is a lot simpler for you to do it on the fly, especially when teachers start to skip steps. Okay, number 14a. Write in ax plus by equals c. So we have the equation y equals 1x minus 8, and we want to turn it into the form ax plus by equals c. We need to remember a few things. The x term has to be positive. So the x term is positive where it is right now. So I simply want to subtract y from both sides. So we're going to get 0 equals x minus y minus 8. Now that is a fine form. So another classic form is ax plus by plus or minus c equals 0. And sometimes the teacher wants it in that general or standard form. So I'm going to circle my answer first of all, because that answer is correct. then I can also add 8 to both sides and mirror it. X minus y equals positive 8. So both of those forms are acceptable for general form unless they specifically tell you to do one or the other. Okay, B. Y equals 1/2 x minus 5. So, first of all, we have a 2 on the bottom. We want to times both sides by 2, the lowest common denominator. When we times 2 by y, we get 2y. When we times a half by 2, it cancels. We get x, and negative 5 times 2 is negative 10. So, x is positive. So I'm going to subtract 2y from both sides, and we'll get 0 equals x minus 2y minus 10. Again, that's a fine form, so I'm going to circle that answer. But let's also add 10 to both sides in case they specifically want it in ax plus by equals c. Let's mirror it. X minus 2y equals 0 plus 10 is 10. Circle your answer. Okay, C. Y equals 8x. Whoops, C, close bracket, excuse me, C. So here we're simply just going to minus y from both sides. And we get 0 equals 8x minus y. Circle your answer. No need to do a final step. Just a little bit of a reminder, no fractions. I'm going to write these down in red. No fractions. Positive x, and in the form above. Okay, we have D. Y over 2 equals negative 2/3 x minus 2. So we want to times both sides by the lowest common denominator. The lowest common denominator between 2 and 3 is 6, times both sides by 6. Now, we're not actually going to times. We're going to simplify as we go. Y over 2 times 6. 6 divided by 2 is 3. So we're simply left with 3y equals negative 2 divided by 3 times 6. Well, 6 divided by 3 is 2 times negative 2 is negative 4x. And negative 2 times 6 is going to be negative 12. So notice the x term is negative. We want to add 4x to both sides because we want the x term positive. And in red, x is first. So we say 4x plus 3y equals negative 12. Again, feel free to add 12 to both sides and get it equal to 0 if that's the form that they want. Okay. Okay, 14e. We have y minus 4 equals 2 open bracket x minus 5. So notice this is in slope point form, and we have to get it to general. So let's start by distributing our 2. So we have y minus 4 equals 2 times x is 2x, 2 times negative 5 is negative 10. So notice x is positive. Let's clean up the numbers first of all. So let's add 4 to both sides just because we can. Y equals 2x. Negative 10 plus 4 is negative 6. Notice the x term is positive. Let's minus y to both sides. So we have 0 equals 2x minus y minus 6. That's a fine answer. Or you can add 6 to both sides and mirror it. 2x minus y equals 0 plus 6 is 6. Circle your answer. Okay, F. Y plus 4 equals 2/3 x plus 6. So let's start by distributing the 2/3. Again, remember, we could times both sides by 3 immediately. You know what? Because we distributed so often, let's times both sides by 3, getting rid of that 3, times 3 times both sides by 3. Sorry about that, technical difficulties. Okay, so on the left-hand side, y times 3 is 3y. 4 times 3 is positive 12. 2/3 times 3, the 3's cancel, we're left with 2 open bracket, x plus 6. We now could divide both sides by 2, but at this point, I don't want to divide the 3 on the left by 2, so I'm going to distribute the 2. So we get 3y plus 12 equals 2x plus 12. So we can subtract 12 from both sides. And then we're going to get 3y equals 2x. Then we can subtract 3y from both sides. And we get 0 equals 2x minus 3y. Circle your answer. Notice, interesting form. We don't even have a number on the other side. Okay, G, top right. We have y plus 2 over 3 equals negative 1 over 2 x minus 3. So we learned a few questions ago that we want to times both sides by the lowest common denominator. The lowest common denominator between 2 and 3 is 6, so we're going to times both sides by 6. Y times 6 is simply 6y. 2/3 times 6. 6 divided by 3 is 2, times 2 is 4, plus 4 equals negative 1/2 times 6. 6 divided by 2 is 3, times negative 1 is negative 3. Then we can distribute, so we get 6y plus 4 equals negative 3x. Negative 3 times negative 3 is positive 9. Then we can clean it up. So let's first minus 4 from both sides. Always clearing out the easy numbers. 9 minus 4 is 5. Now notice x is negative, so we have to add 3x to both sides because x has to be first, x has to be positive, and we can be in that form. Circle your answer. Feel free to subtract 5 from both sides to get it equal to 0 if you like. So that's going to be what we call general form. So now we've seen all the forms. Y equals mx plus b. Slope-intercept form, y minus y1 equals m open bracket, x minus x1. Slope-point form, and ax plus by equals c, or ax plus by plus or minus c equals 0, general or standard form. All right, number 15, graph. So 15a, we are graphing in the form y equals mx plus b, y equals mx plus b, where m is the slope and b is the y-intercept. So if we have the equation y equals x plus 1, we can simply draw a graph. We have a y-intercept of positive 1, and there's a 1 in front of x, and it's over 1, so we have a slope of 1, up 1 over 1, down 1 over 1, put a line through it with arrow tips. Y equals x plus 1. B, y equals negative 2x plus 4. So this time we're going to draw the x-axis a little bit lower because we need a y-intercept of 4. 1, 2, 3, 4. And then we have a slope of negative 2. The negative 2 is over 1. So we simply go down 2 over 1 in the negative direction. Down 2 over 1. Put a line through it with arrow tips. Okay, C. 15c, y equals negative 3 over 4x plus 2. Okay, so let's draw a graph there. The x-axis can be okay because we just need a y-intercept of positive 2. Then we simply have a slope of negative 3 over 4. So down 3 over 4, put a point, and draw a line through it. Okay, D. Y equals 1/2 x minus a half. So we can draw that. So we have a y-intercept of negative 1/2. Now we have to go up 1 over 2, and then again up 1 over 2. And notice we don't get these nice clean points. So sometimes it's very helpful. If you're going up 1 over 2, you can simply go up a half over 1. up a half over 1, up a half over 1, and fill in all those points. That may be very useful for other math a little bit later. Okay, 15e. So we have the equation y equals 5. Well, I don't really know what that is, but I know where y is 5, so I'm going to draw a graph and put the x-axis really low, and put a point on the graph 0, 5, where y is equal to 5. Now, where else is y 5? Well, y 5 here at 3, 5, and it's here at negative 1, 5. So I can draw a line through my points. Y equals 5. Okay, x equals 2, EF. X equals 2. So we can draw a graph. Now where is x2? Well, x is 2 here at the x-intercept, 2, 0. And it's also 2 here at 2, 2. It's also here at 2, 3, all with the same x value. We know the equation is straight up and down. G, x equals 0. So where is x 0? So x is 0 on the y-axis, here at 0, 0, here at 0, 1, etc. The line is straight up and down. So the equation of the vertical y-axis is x equals 0. And vice versa, in blue, the equation of the x-axis is y equals 0. So be very careful with those equations. Very helpful with the equations x and y equals to simply start drawing points where x is that or y is that, then draw a line through it, then you'll clearly understand if it's a vertical or horizontal line. Okay, 16a, graph. Now, these are in the equation ax plus by equals c. So, first things first, we have 3x plus 2y equals 6. Okay, so one thing we can do, I'm going to do that off to the right, is take that equation 3x plus 2y equals 6 and turn it into y equals mx plus b. So we can start off by subtracting 3x from both sides and say 2y equals negative 3x plus 6. Then we can divide both sides by 2. Therefore, y equals negative 3 over 2x plus 3. Circle that partial answer. I'm going to do that circle again. So circle that partial answer. So we could just do that and then we could just graph that. But an extremely useful tool is going to be a table of values for x and y, and simply put 0 in the x column and figure out what y is, and 0 in the y column and figure out what x is. So let's start by putting 0 in for x. So we're going to get 3 times 0 plus 2y equals 6. 3 times 0 is 0. 3 times 0 is 0. It's gone. We can divide both sides by 2, and we'll get y equals 3. Circle your answer. Put it in the table. Okay, then we can make the y value of 0 and substitute it. So we're going to get 3x plus 2 times 0 equals 6. And then we can cancel 2 times 0 because that's 0. We can say 3x equals 6. And we can divide both sides by 3. X equals 2. We can put that in the table. Then we can draw our 2 points that we just figured out. So if we draw a graph, we have an y-intercept of 0, 3. We have an x-intercept of 2, 0. We can put a line through it and confirm with y equals mx plus b. Do we have a slope of negative 3 over 2? Yes. Do we have a y-intercept of 3? Yes. So, in big blue, a table of values. Choosing 0 for x and 0 for y is going to be a great tool, not always, but a great tool for the equation ax plus by equals c. Again, remember, if you would feel more comfortable turning it into y equals mx plus b and graphing it that way, feel free, no problem, all the same. But it's a great way to check your answer, doing it in 2 different forms. Okay, we have 16b. So we have 2y plus 3x plus 6 equals 0. So extremely similar to the last question. Do you have to subtract 6 from both sides? No, but it's a great idea to start. So if we subtract 6 from both sides, 2y plus 3x equals negative 6. We can then make a table of values and say x and y. We can put 0 in the x column and 0 in the y column separately. We can start by putting 0 in for x. So we're going to get 2y plus 3 times 0 equals negative 6. 3 times 0 is 0, so it's gone. So we have 2y equals negative 6. Then we can divide both sides by 2. Then we can get y equals negative 6 divided by 2 is negative 3. Circle our answer, put it in the table. Then we can put 0 in for y, so we have 2 times 0 plus 3x equals negative 6. 2 times 0 is 0. 3x equals negative 6. Divide both sides by 3. X equals negative 2. Circle your answer, put it in the table beside y. Then we can graph it. So we have a y-intercept of 0, negative 3, and an x-intercept of negative 2, 0. And then we can put a line through it, and we don't have to dangerously convert it into y equals mx plus b and potentially make mistakes. But great idea to do it in both ways sometimes. Very helpful. Okay, 16c. 2x plus 5y equals 10. Okay, so we can make a table. We can say x and y. We can put 0 in the x column and 0 in the y column. This time I'm going to do it way more in my head. If x is 0, the x term is gone, and we get 5y equals 10. Divide both sides by 5. Y equals 2. Circle your answer. Put it in the table. Now, when y is 0, the y term goes away, and we're left with 2x equals 10. Divide both sides by 2, x equals 5, put it in the table, then graph it. So we have I need to move my y-axis 1 to the left or else I will run out of space. So I'm going to put on my y-intercept 0, 2, and my x-intercept 5, 0, and put a line through it. Again, feel free to turn into y equals mx plus b if that makes you feel more comfortable. Okay, 16d. So we have 3x plus 4y equals 6. So make a table of values. X and y, 0 in the x column, 0 in the y column. So when we put 0 in for x, we get 4y equals 6. Divide both sides by 4, and we get y equals, simplify the fraction, 3 over 2. Put 3 over 2 in the table. That's the only time I use an angled slash fraction, when I absolutely have to. Okay, when I take 0 and I put it in for y, we are going to get 3x equals 6. Then we can divide both sides by 3, and x equals 2. Put it in the table. Okay, so let's draw a graph. So we have a y-intercept of 0, 3 over 2. 3 over 2 is simply 1.5, so 0, 1.5. And an x-intercept of 2, 2, 0. So not as confident with this one with the decimals. So I'm going to turn this one into y equals mx plus b to feel more confident. 3x plus 4y equals 6. Subtract 3x from both sides. 4y equals negative 3x plus 6. Divide both sides by 4. Y equals negative 3 over 4. X plus 6 divided by 4 is simplified to be 3 over 2. Circle our answer. So we can clearly see that we have a y-intercept of 1.5 or 3 over 2, so that's good. But do we have a slope of down 3 over 4? Well, let's continue this slope. So we go down 1.5 over 2, down 1.5 over 2, down 1.5 over 2, extend that, and we can clearly see that we have a slope of down 1, 2, 3, 4, over, down 3, excuse me, down 3, down 1, 2, 3, over 1, 2, 3, 4. So very interesting questions sometimes. Very good idea to check your answer by not only making a table of values and substituting 0 in for x and y separately and drawing the graph, but also converting it into y equals mx plus b and making sure that everything is correct in the end. Okay, 17a. So these equations are in y minus y1 equals m open bracket x minus x1. Put a box around our general formula. So we can say y minus 1 equals, 16a, y minus 1 equals 2 open bracket x minus 2, where we clearly have a slope of 2 and a point of opposite of attached to the x, opposite of attached to the y. So we can draw that graph. So we simply have a point of 2, 1 and a slope of up 2 over 1 in both directions. Draw a line through it. So slope-intercept form and slope-point form are going to be a lot easier to graph than general form, usually. So then we have y plus 1 equals negative 1/2 x minus 2, where we have a slope of negative 1/2, and we have a point of opposite of what's inside the brackets with x, 2 comma, opposite of what's inside the bracket or with y, negative 1 comma. We can draw that graph. So we have the point 2, negative 1, and a slope of up 1 over 2, up 1 over 2 in the negative direction. I forgot to label my point 2 comma negative 1. Great. C. So we have y minus 1 equals x plus 2. Well, technically there's brackets around this x plus 2 and there's a 1 in front. So we know that the slope is 1. So we can say m equals 1, and our point is opposite of what's inside the brackets with x, negative 2 comma, opposite of what's attached to the y, positive 1. Then we can draw our graph. So we have the point negative 2 comma 1 and a slope of 1, up 1 over 1, up 1 over 1. Who cares that my graph looks funny? Okay, question 18a. So find the equation of the line. So let's start off with a point. We have the point, a y-intercept of 0, 1. And then we have a slope of up 1 over 2, again up 1 over 2. So we can say y equals mx plus b, and we can substitute y equals, our slope is 1/2, x, and our y-intercept is positive 1. That is going to be the easiest way. We could have chosen a point and gone into slope point form or whichever. The next equation, well, I'm going to identify some points. We have a y-intercept of 0, 3. We have another point of 3, 3. We have another point of negative 2, 3. What's the same the whole time? Y. What's y the whole time? Y equals 3. Circle your answer. This next equation, we have a point of negative 3, 0. We have another point of negative 3, 2. X is the same the whole time. X equals 2. Okay, we have a y-intercept of, that was B and C. We're now on to D. We have a y-intercept of 0, negative 1, and then we have a slope of up 3 over 1 in the negative direction. So y equals our slope, negative 1/3 in the negative direction, x minus 1, our y-intercept, finding the equation. You could obviously convert it to any other equation that you want, as we've seen previously in the exam review. But specifically, if they just ask you for an equation, you can give them the laziest equation or the equation that you like the best. And if they ask you to give you a specific one, then you choose the one you like the best, and then from the previous notes, convert it. Okay, 19a, parallel and perpendicular slopes. So first of all, if they give us a slope of -2, the parallel slope m represented by sub two vertical parallel lines is going to be the same slope. So let's put that on a graph. So if we draw a graph, I'm going to pick any random point that I want and simply first do a slope of -2 up 1/2 in the negative direction. And then we do a parallel slope. Well, that's going to be pick any other random point, up 2/1, up 2/1 in the negative direction. We get two parallel lines, lines that never touch. So now let's do m perpendicular in red. So m perpendicular is represented by m sub upside down capital T equals the negative flip. So the -2 is over 1, so I'm going to multiply by -1 and flip it. And that will be my negative reciprocal slope. So now if I choose either of these two, and I take this point, for example, and go up 1/2, up 1/2, and put a line through it, what happens is that they meet at 90 degrees. And that's what a perpendicular line will look like. Any line with a slope that is the negative reciprocal of the other line, and they meet at 90 degrees. Okay, B. So we have m equals 3/2. Okay, so the parallel slope, m parallel, will just be the same slope, and m perpendicular will just be the negative reciprocal. So it's multiply it by -1 and flip it. Okay, C. m equals 0. So the parallel slope will be m equals 0, and the perpendicular slope, well, if we have a line with a slope of 0, a line that meets it at 90 degrees will be a vertical line, and that slope will be undefined. Very careful with parallel and perpendicular slopes. Parallel, same slope. Perpendicular, negative reciprocal slope. Multiply by -1 and flip it. Okay, parallel and perpendicular lines again. 20b. Or 20a, excuse me. 20a. So it says find P if the lines are parallel and if they're perpendicular. So let's start off by writing down the given slopes. M equals P/5 and M equals 2. So in order for these to be parallel, they just have to equal to each other. So P/5 equals 2. Then if we times both sides by 5, we get P equals 10. Then we can check our answer by putting it back in. So if P is 10, we can say 10/5, which equals 2, so we know we are correct. Okay, so perpendicular lines, well, P/5 would have to equal the perpendicular of the other one. So basically we flip it and make it negative. Remember, the 2 is over 1. So now we have a 5 on the bottom and a 2 on the bottom. We want to times both sides by the lowest common denominator. 10 times 10. On the left-hand side, we are going to be timesing it by 10. So 10 divided by 5 is 2, so we get 2p. On the right-hand side, we get -1/2 times 10. 10 divided by 2 is 5, so we get -5. And we can divide both sides by 2. P equals -5/2. Circle your answer. So now we can check our answer. So if m equals, if we get a p-value of -5/2, that's still over 5 from the given in the beginning. Well, that's -5/2. And now the 5 on the bottom is over 1. So we are dividing by 5/1, or simply multiplying by the reciprocal. And the 5's cancel, so we're left with -1/2, which is the perpendicular slope of 2/1 from above. Therefore, we know it's correct. So there's a p-value if it's parallel, and there's a p-value if it's perpendicular. If it's parallel, we just make them equal to each other. And if it's the perpendicular, we flip one, make it negative, or multiply by -1, and then make them equal to each other. So let's see that again. Okay, we have 20b. So we have a slope of m equals 8/p, and we have a slope of m equals -1/2. So for parallel, we're going to make them equal to each other. 8/p equals -1/2. Now notice we have a p on the bottom and a 2 on the bottom. We want to times both sides by 2p, the lowest common denominator. Keep in mind you can do that separately. Multiply both sides by p, then multiply both sides by 2. So on the left-hand side, the p's are going to cancel. 2 times 8 is 16. And on the right-hand side, the 2's are going to cancel, and we're just left with -p. Divide both sides by -1, and we get p equals -16. Circle your answer. For perpendicular, we're going to flip 1 and make it negative. So 8/p equals, flip it and make it negative. So multiply by -1, we'll get positive 2/1. Flipping and multiplying that by -1. So the 1 on the bottom is useless, so cross it off. We have a p on the bottom. We're going to times both sides by p, and we get 8 equals 2p. Divide both sides by 2, and we get p equals 4. Circle your answer. So again, remember, parallel slopes make them equal to each other. Perpendicular slopes make one of them equal to the negative flip of the other. Okay, 21a. Are the following parallel, perpendicular, or neither? So let's say y equals -2x plus 1, and y equals 2x plus 4. So in the first equation, we have a slope of -2. In the second equation, we have a slope of 2. They're not parallel. One of the slope is not the negative flip of the other, therefore neither. Circle your answer. Neither parallel nor perpendicular. Okay, B. 0 equals 3x plus 5 minus y, and 3y equals -1x minus 6. So in order to properly be able to see the slope, we should get this into y equals mx plus b, where we can clearly see what the slope is. In the first equation, we're going to simply add y to both sides, and we'll get y equals 3x plus 5, where our slope is 3. In the second equation, we're going to divide both sides by the coefficient of y. We're going to get y equals -1/3 x minus 2. Our m is -1/3, and they are negative reciprocals of each other because the 3 on the left is over 1. I'm going to circle all my slope values just because. And they're the negative reciprocals of each other, therefore the slopes are perpendicular. Okay, C. So we have y minus x minus 9 equals 0, and we have y equals x plus 2. So the first equation, we're going to add x, and we're going to add 9. We're going to add x, and we're going to add 9. So we're going to get y equals x plus 9. We have a slope in front of 1, so we can say m equals 1. Off to the right, we have m equals, we have a 1 in front of the x, so m equals 1. These slopes are the same, therefore parallel. So whichever equation they give you, either slope-intercept form or slope-point form or general form, we need to convert it into a form that you can clearly see the slope, like y equals mx plus b, then compare the slopes and decide if they're different slopes that aren't the negative reciprocals of each other, they're neither. If they're the same slope, we're parallel, and if they're the negative reciprocal of each other, they are perpendicular. Okay, 22. Find the equation of the line through the point, 6, 0, and perpendicular and parallel to the points through negative 4, 9 and negative 7, 10. So the first thing we're going to do is we're going to find the slope of these. So m equals y2, 10 minus y1, 9 over x2, negative 7 minus x1, negative 4. M equals 10 minus 9 is 1. Negative 7 plus 4, negative 7 plus 4 is negative 3. Therefore, we have a slope of that. Now, let's circle our partial answer and start by saying m parallel would be negative 1/3. And m perpendicular would be positive 3. So now we're going to do it first with the equation y equals mx plus b, taking the slope and substituting it in. So this will be parallel, negative 1/3 x plus b. And let's do it immediately with perpendicular. Y equals 3x plus b. Then we have a point at the top, x comma y, so we can carefully substitute those values in. So we have a y value of 0, so 0 equals negative 1/3 times 6 plus b. And then we have y equals 3 times 6, 0 equals 3 times 6 plus b. So if we mirror this equation, b equals 18. And in the other equation, 0 equals negative 1/3 times 6 is simply negative 2 plus b, adding 2 to both sides. B equals 2, mirroring it. And in the last one, I got it incorrect, so I'm just going to redo that quickly. 0 equals 18 plus b. If I subtract 18 from both sides, b equals negative 18. And rewrite them both. Y equals negative 1/3 x plus 2, our parallel equation, and our perpendicular equation, y equals 3x minus 18. Circle your answer. So very similar to questions before when we had 2 points, finding the slope, then using our knowledge of parallel slopes, same slope, perpendicular slopes, negative reciprocal slopes, then finding the equation of both lines. Feel free to graph both of these and make sure that they're both perpendicular going through that point. Okay, 23 probably should have been before 22, but 23. We have the point 1, 7 and the point negative 3, negative 1. What is the slope of the line parallel and perpendicular to this? So m equals y2 minus y1 over x2 minus x1. M equals negative 1 minus 7 is going to be negative 8. Negative 3 minus 1 is going to be negative 4. Therefore, simplify. Negative divided by negative is a positive, and 8 divided by 4 is 2. So the parallel slope would equal 2, and the perpendicular slope would equal the negative reciprocal. Again, very similar to the question before, a little bit easier. Don't know why I did it in that order. All good. We found a slope, and then we gave them the parallel slope and the perpendicular slope to this. Okay, 24. So find an equation parallel and perpendicular to the following line passing through the following points. So we have the equation y equals 2x plus 1 and the point 3, 5. So they want a line, the equation line parallel and perpendicular through that point. So our parallel slope is m equals 2, and our perpendicular slope is the negative reciprocal, a half. Now we just have a slope and a point. Let's start off with y equals mx plus b. And we can carefully substitute the parallel slope. And we can carefully substitute the point from above, x comma y. So we have an y value of 5, so we can put that on the left-hand side. We have an x value of 3 on the right-hand side. And then 2 times 3 is 6. And we can minus 6 from both sides and mirror it. B equals 5 minus 6 is negative 1. And rewrite the equation. Y equals 2x minus 1. Circle your answer. The parallel equation through the point given. Now we've got y equals mx plus b, so we can carefully substitute in the slope first. Then we can take the point, substitute in for x and y. Y is 5. X is 3. Clean it up. 5 equals, so negative 1 times 3 is going to be negative 3 over 2 plus b. Now I could add 3 over 2 to both sides, but I'd rather multiply both sides by 2. When I multiply the first fraction by 2, but the first number by 2, 5 times 2 is 10. When I multiply negative 3 over 2 by 2, it cancels. We're left with negative 3 plus b times 2 is 2b. We can add 3 to both sides. 13 equals 2b. We can divide both sides by 2, and we get b equals 13 over 2. Therefore, y equals the negative reciprocal slope, negative 1 over 2, x, plus 13 over 2. Don't be afraid of fractions. Okay, 25, a little bit on function notation. So, first of all, in 25, they've given us information, f of x equals x plus 2. So, then, the first question says f of 3 equals, question mark. Well, we just put 3 in on the left-hand side for x, so we're just putting 3 inside for the right-hand side for x. All this question is saying is let's make a table of values and put 3 in for x. So if we put 3 in for x, we're going to get 5. F of 3 equals 5. Circle your answer. I'm going to put it in the table just for fun. Now they've said f of x equals 6. X equals question mark. So this time we're going to take the 6 and put it in on the left-hand side. 6 equals x plus 2 from above. This is b. Then we can simply subtract 2 from both sides, and x simply equals 4. Circle your answer. So now, in the table, when y was 6, x is simply 4. Okay, C. F of x plus 5. Well, we just learned in A that f of 3 meant put 3 in for x. Well, f of this means put this in for x. So it's x plus 2. So we're simply going to take the equation from above. I'm going to put a box around it because we keep using it. And simply substitute x plus 5 in for x. Clean it up, and we're just going to get x plus 7. Therefore, f of x plus 5 just equals x plus 7. Carefully just putting what's inside the brackets in for x. So D, f of 3x. In blue, again, we're using the same equation from above, and we're simply going to put 3x in for x wherever you see an x, and we're good. So they either give you an x value and you put it in for x, or they give you a y value and you put it in for y. What we want to remember top right is that y and f of x for now are extremely the same and interchangeable. They're not exactly the same, which we're going to learn in the future, but for now we can really consider f of x as y. So if they tell you what f of x is, that's just a y value, and we can simply put it in for y or f of x. So remember, the equation from the beginning, f of x equals x plus 2, is simply y equals x plus 2. And f of x and y will be completely interchangeable for now. So again, remember, if they give you an x value, put it in for x. If they give you a y value, put it in for y. This stuff should be no more difficult than making a table of values. Okay, a little bit more complicated function notation, number 26. So f of x equals negative x squared plus x. And they're first of all in A asking for f of negative 1. So that simply means take x and put negative 1 wherever you see an x and very carefully substitute with brackets. So we have negative 1 squared plus negative 1. So f of negative 1 is equal to negative 1 squared is 1 times negative is negative 1. Positive times a negative is a negative. Therefore, f of negative 1 is simply equal to negative 2. Circle your answer. Maybe make a table so it makes you feel better. X, y. When x was negative 1, y was negative 2. Okay, now B. They're saying that f of x equals negative 2. What's x? Well, this time we're going to take our equation from above. I'm going to put a box around it. We're going to keep using it for all of this question. And this time it's a y value of negative 2. So we're going to put negative 2 in on the left-hand side of the equation. It's negative x squared plus x. Then we can simply solve this equation by adding 2 to both sides. Therefore, 0 equals negative x squared plus x plus 2. We're going to divide both sides by negative 1. 0 equals x squared minus x minus 2. Now, we're just going to quickly learn a more advanced topic from next year. So everyone remembers how to factor this thing. 0 equals, from factoring in the last chapter, two numbers that multiply together to make negative 2 and add to get negative 1 are simply negative 2 and positive 1. And then we're multiplying two things together to make 0. We can separate them. X minus 2 equals 0 and x plus 1 equals 0. We can add 2 to both sides and we can subtract 1 from both sides. Clean that up a tad. And then we can say x equals 2 and x equals 1 and circle both answers. So we have multiple answers. Next year we're going to learn a new type of graph. So this year it's all about the line and next year it's all about the parabola. So I'm just going to draw this for you. So we simply have values of, one quick moment. I'm going to put in the graphing calculator just to cheat so I don't make any mistakes. Negative x squared plus x, and then graph it with a table of values. We have x, y, and if I check out the table, we're going to have the points negative 1, negative 2. We're going to have the points 0, 0. We're going to have the point 1, 0. And we're going to have the point 2, negative 2. So let's put those points on the graph. Negative 1, negative 2, 0, 0, 1, 0, and 2, negative 2. We get this parabolic shape where we actually have two x values. Excuse me. Off to the left should say x equals negative 1. We have two values. So we have negative 1 comma negative 2 and we have 2 comma negative 2. So be very careful with that. I'm not going to do that very often. That was actually an accident that happened. But remember, we don't always just have one value. We can have more than one value. But f of x and y are completely interchangeable, and we're simply having x values and finding y values, or having y values and finding x values. Okay, 27, more on function notation. So everyone knows the formula, a equals pi r squared. That is a formula in variable notation, whereby the equation is just area equals pi r squared. But the way we want to write that now is a of r equals pi r squared. A little bit more on function notation. So if y is equal to mx plus b, we say y is a function of x, which can be written that way. There's a bunch of these. But basically, the formula on the left-hand side just includes brackets with the variable on the right-hand side. So they're saying solve for r if a is 5. So we're basically finding a of 5, which just means pi times 5 squared, which is equal to 25 pi, or a very valid answer, or we can simply do 25 times pi in the calculator, and we'll get 78.5. And then we want to include our units, centimeters squared. So a of 5. So that's kind of confusing. But what we should write down is an English sentence. The area when r equals 5 is 78.5 centimeters squared. Much better allowing you to go back and remember what that means in your notes, because if you just write an answer, it's going to be very difficult to see. But if the equation is a of r is equal to pi r squared, that just means that we're looking for the area as a function of r. We're going to learn a lot more about functions. We learned a lot about functions and vertical line tests and what is a function and what isn't a function. But this is what we call function notation. Okay, excuse me, I forgot to write A. So now we're doing 27b. So we have another equation. So we have a cost function. C of x equals 100x minus 500. You don't know that it's a cost function. I do, but C equals. So find x if c of x equals 500. So now they're telling us that c of x is equal to 500. So is this an x value or is this a y value? Well, this is a y value, so we're going to substitute on the left-hand side of the equation. So c of x is 500. We can add 500 to both sides. So 1000 equals 100x. And we can divide both sides by 100, so x equals 10. Again, an English sentence. X is 10 when c of x equals 500. So function notation, not much difficult than just making a table of values and substituting in for x and y. We just need to understand that it's just that simple. Okay, 28a. We have the point 1, 3 and the point 5, 6. So we're going to find the distance. So let's first graph these points. So let's take a graph and put the point on 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 5, 6, and the point 1, 3, 1, 3. We want to find the distance between these 2 points, so I'm going to draw that line. So remember that we just have a right angle triangle. We have this and this. And we want to remember that this distance here is just x2 minus x1. And this vertical distance is just y2 minus y1. So if we take Pythagoras' theorem, a squared plus b squared equals c squared, and square root both sides, and mirror it, c equals the square root of a squared plus b squared. Now c, we're going to call d the distance, the hypotenuse, therefore d equals the square root. A's distance is just x2 minus x1 squared, and b's distance is just y2 minus y1 squared. And we have proven what we call the distance formula. So we're not going to keep doing that. Just remember, you can always put them on the graph and just figure out what the lengths are and then just find it. Outside of that, let's find it. So d equals the square root of x2 is 5 minus x1 is 1 squared plus y2 is 6 minus y1 is 3 squared. So that's going to be d equals the square root of 4 squared. 5 minus 1 is 4 squared is 16. 6 minus 3 is 3 squared is 9. d equals the square root of 16 plus 9 is 25. And therefore d equals 5, the distance between them. Feel free to draw those on a graph and measure it. Okay, 29b. So we have the points 0, negative 1, and we have the point 3, 1. So let's use the distance formula. So d equals the square root of x2, 3, minus x1, 0 squared, plus y2, 1, minus y1, negative 1 squared, which is d equals 3 minus 0 is 3 squared is 9, plus 1 minus negative 1 is 1 plus 1, which is 2 squared is 4, and we get d equals the square root of 13. Who cares that it's a root? Feel free to convert that into a decimal if they ask you for a decimal, and round it if you like, but that is what we call exact value. Feel free to draw those on a graph. So we have the points 3, 1, and we have the point 0, negative 1, and we have an x distance of 3 and a y distance of 2, and we have a hypotenuse of root 13. Feel free to simply check that with basic Pythag. Keep in mind, you might not have a graph paper, or you might get really annoying looking points. Either way, you're going to use exactly the same formula in the box, and then figure out what the distance between those 2 points are. Okay, we have 29a. Find the midpoint between 2 points. We have the point 1, 1, and we have the point 5, 3. So let's first understand that a little bit better, drawing it on a graph. So again, we have the point 1, 1, and 1, 2, 3, 4, 5, 3. So notice we could just count. Up 1 over 2, up 1 over 2. Therefore, we absolutely know that the midpoint is simply 3, 2 by counting. But we want to learn a formula. So what we have to do is we need to average this distance and average that distance. And the way we're going to do that is following the formula. M equals x1 plus x2 divided by 2, comma, y1 plus y2 over 2. Notice not minus and plus. We're just averaging x values and averaging y values. So that is the formula. I'm going to put a box around it. Therefore, m equals x1, 1 plus x2, 5 over 2, comma, y1, 1 plus y2, 3 over 2. Therefore, the midpoint will simply be 1 plus 5 is 6, divided by 2 is 3. 1 plus 3 is 4, divided by 2 is 2, and we have our midpoint. So notice we can graph it and count, but they're probably going to want you to write down the formula and substitute in the formula and give them the answer. Okay, so now we have B. So we have the point 1, negative 3, and we have the point 5, 5. I'm not going to draw it again. Well, you know what, I probably will in the end. So let's substitute straight into the formula from above. So if we average the x values, 1 plus 5 over 2, and average the y values, negative 3 plus 5 over 2, we're going to get m equals 1 plus 5 is 6, divided by 2 is 3, Negative 3 plus 5 divided by 2. Negative 3 plus 5 is 2, divided by 2 is 1, and we get our midpoint. So let's check to make sure that that works. So if we draw a graph and put the point on 1, negative 3, and the point 5, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and then know that we're going up 1, 2, 3, 4, 5, 6, 7, 8, up 8, and over 4. Well, we have a slope of m equals 8 over 4. We can simplify that fraction to be 2. Then we can go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. And we can clearly see that we have the point 3, 1 as our midpoint. Again, they're probably not going to give you as nice clean values. You might get decimals, you might get fractions, etc. But all we're doing is finding the midpoint between 2 points by averaging the x values and averaging the y values. Okay, the toothpick problem, question 30. So the following diagrams are made of toothpicks. So let's copy those diagrams down. So dot, dot, dot just means it goes on forever. Okay, so it says create a table of values and find the number of toothpicks. So we have to get some let statements going. So let t equal number of toothpicks, and let d equal the diagram number. So if we make that table of values, we're going to start off by saying x and y, and we're going to cross out x, and we're going to cross out y. So what depends on what? Well, y depends on x. Well, the number of toothpicks depends on the diagram, so d is x and t is y. So the x values that we're going to choose are 1, notice I skipped a line in the table, 2, 3, 4, 5, etc. And the number of toothpicks in the first diagram is 4. Then we're only adding 3 toothpicks each time. So then 3, then, 7. 4 plus 3 is 7, plus 3 is 10. And then we could continue that pattern. So now it's saying find the number of it wants the equation first. So let's come up with that equation. So first of all, we're going to do it the hard way, then the easy way. So first of all, we have 2 points on a graph, and we'll find the slope. y2 minus y1 over x2 minus x1. Then we can write down the equation, y equals mx plus b, and substitute that in an equation. So we have y equals 3x plus b. Then we can carefully take one of our points, for example, 1, 4. 4 equals 3 times 1 plus b. 3 times 1 is 3. And we can minus 3 from both sides. And then we can rewrite it. Y equals mx plus b. So y equals 3x plus b. Then we can put our variables back in. So our y value, looking at our table, is t. T equals 3. Our x variable is d plus 1. Our equation in y equals mx plus b form, t equals 3d plus 1. Now back up the table. Couldn't we have just thought about it and been like, well, t looks like d plus 3. Oh, nope, that pattern doesn't continue. Okay, what about t equals 3d plus 1? Oh, that totally works. Circle your answer. So we can do it properly, finding the slope using 2 points and then substituting the equation, or we can just logically thinking about it. Remember, cancel the things that you don't use, that you've thought through, so you don't have to re-go through and think about all the other ones again. Okay, find the number of toothpicks in the fifth diagram. So again, let's do it the hard way. So let's take the equation. Creating the equation, the table of values was A, and so was the equation A. Now we're going to work on B below the table. So let's start by writing down the equation. T equals 3D plus 1. Then it says find the number of toothpicks in the fifth diagram. So that is in the fifth diagram. So that means T equals 3 times 5 plus 1. Therefore, T equals 3 times 5 is 15 plus 1 is 16. Circle your answer. So, C. Now it says find the number of toothpicks in the, find the diagram number with 13 toothpicks. So this time T equals 13, and we have to take the equation T equals 3D plus 1, and this time put 13 on the left hand side of the equation, minus 1 for both sides. I am going to run out of space in a second. I'm going to divide both sides by 3. Therefore, D will equal 4. Now I'm going to put those values in the table in red. So in B, we found out in the fifth diagram there were 13 toothpicks, and in C, we had the fact that there were 13 toothpicks, and we figured out the fourth diagram. Feel free, you could actually draw all of the different diagrams of all the toothpicks. But a classic question. So they'll give you some information, you'll make a table of values, you'll either find the equation using slope and y equals mx plus b, or simply thinking about it using logic. Then we're going to be using that formula to ask questions either about the independent variable x or the dependent variable y. This is going to be a very good question to build up into arithmetic sequences and series, and also systems of equations.